Hello and welcome to lesson 4.3, solving quadratic trigonometric equations. So today what we're going to do is we're going to solve some quadratic trig equations, which are similar to linear trig problems and also some quadratic trig problems. Most of these problems that we're going to look at are either going to be already in factored form for us, or you can factor. Most of the time you'll see them have exponents like 2 that'll allow you to use any of your given trigonometric expressions to change it and work it out. Okay? Most of these ones will also be only solved on the interval from 0 to 2 pi. Unless your angles change, then there's a possibility that it might only be from 0 to pi. So let's try this one on the interval from 0 to 2 pi for the values of theta. Well, first notice that right here we have a cosine, we have a sine, and a sine. So a cosine function and two sine functions, they do relate to each other, and it might be easier to actually change a cosine into a sine. So first of all, recall that a cosine squared theta is equal to 1 minus sine squared theta due to our Pythagorean identity. So what we're going to do is we're going to change that. Just that part right there. So that now we have everything in terms of only a sine function. And now we're going to gather terms and simplify. So I got a negative 2 sine squared theta minus 2 sine theta is equal to 0. So you'll notice that here there is no possibility for the values to equal a constant, so that minus 1 and the plus 1 cancel out. Now what we can do is we can common factor here. So if you think of this as that the sine theta function equal a variable, let's call it x, then you get negative 2x squared minus 2x is equal to 0. And you can common factor out a negative 2x, and you're left with an x plus 1. Well, similarly, this can common factor out a negative 2 sine theta from both of these negative 2 sine squared thetas and negative 2 sine theta, and you're left with sine theta plus a 1. From here, you can solve each of these individually. So you can solve for when negative 2 sine theta equals 0, or you can solve for when sine theta plus 1 equals 0. And that's just solving as you would. So sine theta is equal to 0. That means theta could be values of 0, pi, and 2 pi. You can verify it by visually graphing sine theta again. Or when is sine theta equal to negative 1? Well, that occurs only when theta is equal to 3 pi over 2. And there you go. That's how you solve these. So not unlike solving linear trig equations, just have to do a little bit more factoring. So let's try this one. Again, we're going to solve for the value of theta in between 0 and 2 pi. These are already all in terms of a sine function, so I'm going to take everything and move it on to one side. A lot easier to solve a quadratic if it's equal to 0. Again, if you need to, you let sine theta equal some other variable. We'll call it x. You factor that one if it's easier for you to factor. So x minus 2 and x plus 1. Then you just change this into something similar. So sine theta minus 2 and sine then you solve each one separately. So here again, sine theta equals -1. We just figured that out in our last slide. That's the value of 3 pi over 2. Again, these values aren't always going to be exact radian measures in terms of pi. You can always find their approximations using decimals as well. Well, this one is sine theta equals 2. Well, if you take sine inverse of 2, you'll notice that you get an error here. So if that's the case, theta has no solutions. Oops. Because remember, sine functions can only exist between the values of -1 and +1. And therefore will never equal values greater than 1 or less than -1. Okay, so let's try one last problem here. So both of these are both in terms of cosine, but one's in terms of a double angle here. Now we do have different formulas for cosine functions, but I'm going to use the one that is in terms of cosine. So -3 cosine theta. I'm going to replace the cosine 2 theta by 2 cosine squared theta minus 1. I choose that one because that only is in terms of cosine. Okay, so now I'm going to just rearrange this expression so that's more familiar for me. I usually write it in decreasing orders of degree. And again, if you need to, let cosine theta in this case equal a variable, we'll call it x. So 2x squared minus 3x plus 1. I can factor into 2x and x. If I multiply by -1 and -1 there, okay, that'll make that equal to -3. Okay. So 2 cos theta minus 1 and cosine theta minus 1 equals 0. So it's just a matter of now solving these. So this is 0 and 2 pi. That one's the easy one. This one, I remember a special triangle. It looks like it. So theta, in this case, is pi over 3. But again, I also remember my cast rule. So if one is pi over 3 right here, cosine is also positive in this quadrant. And this big angle is 2 pi minus pi over 3. Or if you wish, 5 pi over 3. And there we go. And thus concludes this lesson.